Hello, Assalamu alaikum. This is Salim Abid from IXL Consulting. Thank you very much for everyone for joining us in this exciting webinar. This webinar first was brought to you by ES Learning, IXL Consulting in collaboration with the Ivey Executive Education. I'm just going to give you a little bit preview what is the Ivey Executive Education, and then we'll go to Professor Yasser to take us through this webinar. So the Ivey Business School is the #1 business school in Canada. They have a branch which is focused on executive education. Alhamdulillah, they are we are excited that we are partnering with them, with the ES Learning, to bring many workshop and executive training to Saudi Arabia, as well as GCC and MENA. And this is what the first webinar we are doing in Saudi Arabia. So we are excited about it. The reality, this is a preview of an actual workshop that we are going to do on December 17 in Riyadh. We are going to be posting more information about that. How can you register to that workshop? But we wanted just to give you a preview, and Professor Yasser is joining us from Canada. So thank you for jumping in. And I know it's early there. It's complicated to coordinate, and especially during this time, which is holidays in Canada and the US. So with that, I will give it, maybe someone from ES Learning can say a few words, and then we give it to the Professor Yasser to take it from here.
Assalamu alaikum. Thank you, Salim. I appreciate the introduction. This is Hamza Al-Raid, Executive Director of ES Learning. As my brother Salim mentioned, we are really excited about this opportunity and collaboration between IXL, ES Learning, and also Ivey Executive Education. ES Learning have been in the market for the last 15 years, and we have been leading a lot of training activities and providing solutions and services. I wouldn't really take the time. I will leave the floor for Professor to move forward with his webinar. Thank you so much, Yasser. The floor is yours.
Assalamu alaikum, brothers and sisters. Do you hear me well?
Yes.
Excellent. So thanks for the opening. I welcome this opportunity to collaborate with the region and the brothers and sisters there. So I'm honored and happy to be here. So what is the plan for today? I think I was thinking that maybe it's a good idea to go through the fundamentals of AI, something that in the past couple of years that I have started going through the region and also teaching in Canada and Europe, especially on AI. I have found it to be probably the most useful way to empower the leaders, the managers, about the decisions they make around AI. So in other words, none of us are going to be computer scientists, but as managers, we need to understand some basic bare minimums about AI, what it is, what are its types, machine learning techniques. And it's important not as a developer. I'm not a developer. I was an electrical engineer probably 25 years ago. But what are the development from managerial perspectives? Because many of these are going to be your decisions, and you're going to be going through a project that is going to be long for development, for implementation, and challenging. But to understand what are the specifics of AI and how it's different from traditional IT is crucially important. It's very important to differentiate it, because sometimes we feel that is it kind of the same thing that we had like IT development and now we change the caption, or is something fundamentally different? And I think managers need to have a quite decent understanding at a big picture level around AI. So this is the agenda for today. I'll try to kind of go for 35 minutes of presentation. Then I will be happy to open up discussion and have questions. And as much as I know, I would be happy to have continue that conversation. So today, a little bit on touch on what is AI and why is it important and how it's different from traditional IT, which is an important understanding for managers. We talk about different types of AI and the risks, and machine learning techniques. Why do I need to know? What are the techniques, and why do I need to know about it? What are the managerial implications? We a lot of it look at the LLMs, probably at one slide or two, not more than that. We're going to discuss it more in the workshop that Salim mentioned. And then we finish with kind of organizational challenges at a high level. Again, I'm carving out this like 30 minutes out of a course that I teach either like 3-4 days to managers or in a traditional university course that is 20 sessions. So definitely we won't cover everything, but some of them I kind of want to open up the conversation and start thinking about that. Let me start by talking about the importance of the managerial perspective, not a computer science, the CS, I mean computer science, and that we as managers, my job is as somebody who want to do it for today and also the sessions that I do with the executives is to simplify technology in a way that is understandable for a manager, to make the managers mindful about those decisions. At the end, you are responsible for it. You're going to have develop an application or buy an application or implement an application, and that's quite important. And you need to know a little bit under the hood what is happening. So I'll try to keep this perspective in our conversation. Let me start with what is the question of what is AI? Why is it important? Because it's interesting, but not surprisingly, there are quite a variation in understanding of what is AI and why is it important has implications for managers. Computer scientists have, with all the variations, they have their own understanding and definitions. Management see differently. Philosophers or neuroscientists have their own views of AI because we talk about intelligence before talking about artificial intelligence and what is intelligence matters. But I found a few of them relevant because it has been having implications for managerial decisions. Probably you have heard about Alan Turing test, the test that says if you're talking, for example, to a chatbot, if you are not able to recognize that was a human or a machine or an algorithm, Alan Turing calls it 1960s around that time, a computer science professor, and that it's that's intelligence. If you can't identify the difference in the behavior of an AI, that's called intelligence. So I caption it as behavioral equivalence. So if the behavior or an action is similar to a human, and I can't recognize whether that was a machine or human, that's intelligence. Then another perspective, some of them has roots in Canadian philosopher Marshall McLuhan, sees AI or technology as an extension of human faculty. So think about a book as an extension of an eye, or a wheel of your car as an extension of foot. And again, AI comes and extends some of your capabilities. Think about Google Map coming in and extends our memory to remember the whole city's map, and that's intelligence, right? So that's a different perspective, quite different from replacing the behavior, but extending, still the human is the intelligence, but the faculty that we have, whether it's the eye, whether it's through the book, whether it's like a clothing that extends the skin with minus 20 degrees that now we have in Canada, those are extension of human beings. But at the end, it's human is in charge and is at the core of the intelligence. The third category is like the one that the godfather of AI, Jeff Hinton, is and his postdoc work on it and kind of promote that, which is like considered as an extended learning. In other words, a mind is replicated by neurons that are extensive, and those are, if you give it the data and train it, something that we do with ChatGPT nowadays, that's going to be learning and it's extended. It's going to through the probabilistic running of the numbers and number crunching, it replicates a sentence that sounds like really like human. But that extended learning, and rather than a human brain, kind of that can replicate a human brain. It's interesting, some of the definitions look at AI as a moving frontier, and I like this because it's kind of an open-ended question. If you think about OCR, we took a picture of a PDF file or a handwriting, and a machine learning algorithm comes and looks at it and spits out the text. That was a big thing probably 10 years ago, 15 years ago. Adobe Acrobat, I remember, was selling this feature. It was a kind of among the features that you have to buy. But now nobody calls it AI. At that time, we were calling it AI 10 years ago. But now we have it in our cell phones. We take a picture, it immediately extracts the text and gives us the text, right? So this definition sees it as not what it is, but what is kind of, it's a moving frontier. Whatever computers have not done so far and they're doing it, that's the AI. And the previous one is kind of a changing, you're not calling it AI. So it's kind of an evolving definition, and I like those that perspective as well. But we're going to come back to some of these definitions, and you will see why I have included them, because it has implications for management and managerial decisions in terms of going with this project or that project, developing it or buying it from vendors. So when we come here, one of the key aspects of the conversation that we have to capture is the notion of what is the difference. We had traditional IT in organizations. We had ERP, enterprise system with all the modules. Yes, we adapted, we customized it, but when it's in place, it works. We had big data for quite a while. How is that different from AI? Are you recaptioning it? Are you selling the same thing in a new box under new caption? I can summarize. So my thinking is that it's fundamentally different in three aspects, which I summarized in this slide. The very first one is the self-learning. So if you think about, we had a kind of a term called rule-based AI. So AI is not a new term. It comes from 1956, I think, in a workshop in Dartmouth College, when mathematicians get together to think whether a machine can learn. They coined the term there. And after we had rule-based AI, that you kind of have the branches of, if that's the condition, do this. If that's that condition, you go through that process. The IBM Deep Blue that beat Gary Kasparov in 1996, if you remember, the first time the world champion of chess. It sounds like a rule-based AI in that the rules of the chess are clear. 200, 300 moves can be done by after an action. Algorithm goes through those and kind of comes back with suggestions, versus human being probably can consider at the same time 10 or 15 moves. So that was the rule-based AI. But what is different nowadays, especially, is the self-learning. What it means that through neural networks that are underneath that, we're going to talk about it in a second, you give it the data and it learns from it without teaching it, without training it, without having the variables and saying that this variable is related to the other variable this way or that way. So that's a very big difference, and that it comes up with its own understanding. It understands our language. When you talk to ChatGPT, it picks up words and tones, and that's the self-learning, and comes back with some output. The other characteristic is that it's autonomous. It means that in contrast to the past, that you have to define a very specific data to rely on and pull out the information from it, it sits on a huge amount of data. And when you ask a question, it autonomously picks up stuff from it, parts of it, and uses that to make an answer for you. It's not your choice. It's not the supervisor's choice. It's autonomously going and doing it. And that's very different from traditional IT. In organizations, we have traditional IT, we have path. If that's not the case, it's going to be error. So it's kind of quite different from that perspective, from a managerial perspective, let's say, not technical. And the last one is the black box. If you ask the question and there's a problem, you keep trying to torture in ChatGPT and asking why, what data you used, and how did you come with that conclusion, it's not very clear. Because ChatGPT, especially today, now more than 2 trillion parameters, it fits a prompt to a data that is most relevant, most probabilistic, and it spits out the answer. It's not very clear for us how it was concluding with that. Even if you know the variables, which is not possible on millions and trillions of variables, it sounds like it's fitting some output to an input rather than really understanding the second time you asked it how it's going to be different from the why was that decision made. So when you ask a question repeatedly from ChatGPT or from Claude or Gemini, the answer is eventually evolving, because every time it self-learns from your question, learns. It sounds like very different from traditional IT. Your prompts changes it. It automatically goes to different parts of the data, and it's not very clear if an error happens or even if the right answer comes to explain how does that happen. So this is another way of illustrating it. So if I want to illustrate that, so if this is a traditional programming in computer science, let's say, or machine learning development in the past, it was more, I don't want to kind of get into the technical discussion, but think about a programmer. A human looks at the input data and writes a program. A program, we sit down and write it, thousands of lines of a program, and we feed it into the computer, and it is able to predict things. So think about a bank. Give the past loans, somebody subject matter expert comes and says, these are the variables, and we write the program, and then we use that program in our department. Rule-based AI is close to that as well. But today's AI is the self-learning that we just mentioned. If you look at the colors, the program was input to the computer. Now it's the output. The output or labels, predictions, or what is the output was the outcome of a program. Now we get from the data, give it to the computer, and the AI algorithm goes through the input and output, cats and dogs pictures, and come up with an understanding of, without telling the technology that it's a cat and dog, it automatically came up with the prediction of that. I think it's 2010 or 12. This was a project in Google Brain that they gave the pictures of the animals without saying to the algorithm anything that what is that animal. And eventually it learned and came up with these categories of cats. They classified it. They may not caption it as cat that we use the term, but captioning cats together, dogs together, and so on and so forth. So that was a revolutionary technology at that time it came. And it kind of, you see nowadays with Monitor in Google YouTube. But anyways, that shows the differences. So if you look at the figure, the picture, the outputs are becoming the input to the computer, and the program is the output with thousands of features that we may or we may not be able to explain. So that's kind of a one way to see how AI is different from traditional IT that we used to have. It doesn't mean that it's bad or good, it's different, so we need to understand. Another follow-up question is, how does the technology or machine learn? There are three categories of generic categories of learning. There's a lot of technical details, many of them beyond my expertise. But the extent that we need to know as managers is that one of the main ones and most used ones is the supervised machine learning. Supervised machine learning, as you see, is like a teacher supervises the algorithm, tells it that this is the credit scoring application, for example, or fraud detection. These are the frauds in the past on credit card. And they tell you, these were the situation, the behaviors, and so on and so forth. And that's a fraud. That's not a fraud. That's a fraud. That's not a fraud. So you kind of label it as fraud or not a fraud. Or in radiology, that's a tumor. That's not a tumor. Or that's tumor type 1, type 2. So you train it, and the algorithm learns from it. Supervised machine learning. The benefit of these applications or this type of learning is more predictable, it's more explainable, but the challenge is the cleaning of the data. You imagine that you need millions of pictures of X-ray and millions of, probably hundreds or dozens of radiologists sit down and hours annotate that, feed it into algorithm and good quality data and label data, which looks backward and predicts the next. Is that the new data when it sees, is that a tumor or not automatically? But the challenge again is cleaning data and labeling, but it's also backward looking. It means that it looks at the past. The other approach is unsupervised machine learning, the one that I just mentioned about Google. So you give it the data, you don't caption. It's easy. Just dump it with the whole information that you have. Customer segmentation is a batch. You have hundreds of variables. You don't know how to segment it. You have a couple of things in mind, but not more than that. But if you look at the online behavior of your bank clients, it comes up with different way of classifying them, and it's data based on the data and evidence. Or think about fraud detection. We can train it supervised based on the past, but it can't predict the future creativity of humans. So unsupervised comes with anomaly detection that goes with thousands of data and different ways of behaviors, and it detects an anomaly happens and flags it. The benefit is that yes, it can capture unknown patterns, which unseen things that is new, it can capture it. It doesn't need labeling, which probably in a hospital it takes you hours and hours. We're going to have this discussion in a hospital over 6 years of transformation, and we are in radiology department in the course when I come, inshallah, to Riyadh. We'll see the difficulty of annotation is gone. Regardless of the industry, you need to annotate the data in supervised. But here it's easy, you just dump it. But the challenge becomes for managers in that things that are coming out of these algorithms are most of the time is so difficult. It has a lot of noise. It has a lot of errors. We call it false positive, means falsely saying that that's a fraud. But that was not a fraud. I was just traveling, and you made a mess out of my travel when you blocked my credit card, right? So those ones should have to clean up and retrain and retrain. So it's a long way after the algorithm starts giving us the output. And it's more unpredictable and uninterpretable because there's lots of data. It just looks at the correlation and flags that. There's a third category that is reinforcement. The previous two were kind of a static. You one time go with the data set, you train your algorithm, supervised or unsupervised, and you're good to go. You put it in the processes, and in your workflows, you integrate it. Reinforcement is the one that it goes with the interaction. So it's kind of underneath is unsupervised, but you put in an environment. Think about autonomous cars. Google started driving its Waymo, that funny little car, in the streets of North America, Europe, Middle East, here and there, because not only capturing the video and pictures of the map of the globe, but also because it drives the car, it gives feedback. When it goes and messes up, we give feedback. Oh, that was good, that was bad, that was good, that was bad. So it's interactive. As soon as it gets feedback, it updates the algorithm, right? So it's a live update. It's very resource intensive. It's very expensive. Apple pulled out of the car, autonomous car driving. It takes a lot of cash. But it's adaptive. So the world, especially environment that are changing all the time, dynamic portfolio management in for banks when the everyday market changes, or the grid management for utility companies for the electricity, it automatically allocates the load on the grid, and based on performance, that whether there was a kind of a red flag on that area versus that one, it updates the algorithm. And that's reinforcement that you see. Why is it important for managers? Because again, it has implications on the type of data that you collect, on the training, on the risk you take. If that project in that industry, I may go with a safer one, with another one, you may go with an alternative. Plus the fact that in reality, successful companies, when you look at it, actually have a mashup of all of these. Netflix is an example. 80% of the viewing of the Netflix, my next movie that I watch or episode that I watch, is from the recommendation. So it's pretty accurate and it's pretty powerful. What is that? It has all the three. It has supervised machine learning to predict what each user will be more likely to like based on some variables. Predictive model is like a supervised machine learning. It has unsupervised based on eventually emerging taste groups and different geographies that are different. So it can kind of spot new things that emerge more forward and be fed back into the algorithm. And it also has some elements of reinforcement, because when it makes the prediction, you give it a thumbs up and down that you liked it or you didn't like it at individual level or collective. And it goes back, feeds back into the algorithm and updates it. So in reality, especially successful companies combine both of them together. In the workshop, we're going to go through a very realistic example. Grow is an application for HR analytics and application. A Japanese company is a company that is pretty brilliant in gamification of the most soft human aspect, human intelligence. The kind of candidates on the job market fill up their survey and also their game, they play it, and it captures their personality characteristics, and it gets it from references. And they made an application that helps companies' HR departments to see who are fit for invitation, or even some of them may replace the HR department, which some of them have done, and some of them for different type of use. But we see an example of a very real development of AI application, how they develop the measure, how the machine learning development cycle happens. But also we look at how it was deployed in the market, with three large companies, including Mitsubishi, ANO, the national aviation company, and Septeni. They adopted the technology completely differently, entirely different use and benefits, and also risks. So we see those three types of machine learning in reality in that case, and they discuss different scenarios. And I'll tell you what happened to the company at the end of that class. Another thing that is quite important to know is the types of AI. We have different way of types of AI, generative and predictive. Predictives are the ones that predict reoffense of a defendant. We have probably seen it. Predict a patient readmission. Predict which music is going to be the next big hit. The generative is like ChatGPT. It generates new words, movies, or for example, this equivalent example on the left side is that it generates a rehabilitation plan for the defendant rather than is that person is going to reoffend or not. Generate or discharge summaries for the patient, and doctor saves doctor or nurse time and so forth. But why I'm bringing this up as a simple classification, because it's quite important when we get to the discussion of the risks of AI. So interestingly, it's very different dynamic for the two. Generative AI, it becomes more risky as it becomes better and better. I mean, nowadays, we get a lot of scam calls. We get a lot of impersonation, probably video calls. I got on scam calls on a daily basis here. And that's an example of last year. 25 million USD fraudsters got out of an employee in finance department of a company in Hong Kong, just impersonating the CFO and a couple of other colleagues. Why it's risky? Because it's really good. It becomes better. And facial recognition was not that good. Nowadays, it's really good. I was reading in news in China. the authorities was able to spot a person over a night music festival or something that had 50 or 55,000 people overnight in the population, spot the person and go out and capture it. So it's really good in terms of the quality, but it becomes risky from that perspective. However, predictive AI is risky because it can never be perfect. It's contrast to that one. In other words, this is an example of a famous application in the United States that was deployed to the judges in the judicial system. So when somebody was captured by the police and in front of the judge has a choice of sending the person to the jail for 2 weeks until the court is there, or sending him home and come back. That's quite an important decision for the person, for the society. And the application was giving me the 133 variables saying that that defendant is a high risk, low risk, or a medium risk. What ended up over the time, it showed that it had some accuracies, but it was penalizing black innocence or have mistake for black innocence twice as much as innocent whites, and vice versa. False negative was also double in that. So what I want to say is that the predictive AI, that especially organizations have a lot of predictive AI and they use it. It can be dangerous and harmful, especially when we think about it, because we're training it on collective data, but we're applying it to individuals, and individual situations are different, and there is scale-up that can be quite scary. I sometimes go with this example. If you feed in a good transportation data on a highway, on a region, you can become pretty accurate in collective prediction in that on this time of year, that type of weather, the number of accidents, for example, becomes triple, right? So it's pretty accurate, but collective prediction. But can you predict individual accidents? Means that, okay, I think this car during this, in 5 minutes, he's gonna have an accident. We can't, right? Because you're running against the context, unlimited number of variables that are emerging, behaviors, and so on and so forth. You can never reliably predict individual decisions based on predictive AI that is trained on collectives. On average, the X is positively related to Y with that coefficient. But is it the case with that person? Probably not. And that's the reason I say when we get to the predictive AI, the very fact that we have the data and we can predict individuals, it doesn't mean that we have to do it. In some areas, think about organ transplant, that people are in line, why somebody gets in front of the line, why algorithm make that decision, and why loved one goes back or comes to the front. Admission interviews for our children, they're going for high school, for universities. Why, based on just the CV, you made a decision not to invite him and no human is involved? Think about quitting a job. If you can predict who is going to quit the job with 80% accuracy, but what about those 20% that because you think that they're going to quit, you're not going to give them training or promotion? Or social services and welfare. In the Netherlands, it led to the resignation of the minister when they used it and they predicted who is the fraudulent, had the fraudulent application, and they made a lot of harm based on that. So having that said, I think managers need to know there are a lot of snake oil AI. I think I have the book. It's a wonderful book if you get a chance when you want to read it. This is AI Snake Oil, but by two computer scientists, and it's kind of a very accessible book in that it shows that you as a manager should be very mindful about these decisions. There's a lot of risk in all types of AI. You see on the right side becomes more predictive AI in biases that we just mentioned, job displacement, using AI in weapons, ethical uses of AI, like the examples that I said, versus generative AI that becomes deepfake, become persuasive AI. Imagine AI knows who I am and gives me ads on healthcare, and I'm a patient on a higher price because they know that I desperately need that type of medication. And they persuade me to buy that product. It's unethical, right? So there's a huge amount of risk in different types of AI, and there are a lot of combination of the two. But that brings me to the notion of it's quite important for us to recognize the differences between different type of claims as managers. There are some of them that are really works. It's a claim that we can accept, and it's pretty benign. So next word prediction in Google when you're typing, that's an example of it, or many fraud detection. There are some of AI applications that I think is still a snake oil, but it's not harmful. Imagine I predict the next music hit. I don't think in music industry or Avatar, the movie industry, entertainment, you can predict things because it runs against an unlimited number of variables that are not bell curve distribution, but Poisson. But anyways, but I think it's not harmful anyway. We can just as a game do it. It's a waste of time and money, but we can do it. But there are some that are not working, means they're snake oil AI, I would say, but they're harmful. So unvetted risk scoring predictive models can be an example. Or the higher an application like grow, you will see that among the companies that adopted it, some of them are harmfully using it. Some of them is very creatively and usefully using it. The same application, I'll show you how it's very different. And we need to be very mindful about that. And that's the last group that is still interesting in that there are some application that actually works. It's really accurate. It's not a fake claim, but it's harmful. Allstate was an insurance company in the States. They ran on a machine learning project that let's see who is the person that if we increase the premium for their insurance monthly, they're not going to switch to another insurance company. And that sounds like a kind of an interesting research question for a company. They did it, they successfully implemented, and it worked. They increased the premium. Most of them didn't switch, so increased the money for the company. But after a lawsuit, it ended up, the investigation shows that it's pretty simple. Why that happened? Most of the people that this was subject to increase and they didn't switch were elderly, 65 years old and above, who are not technology literate, who are not in good situation. Nobody's there to help them to go and search another insurance company. So they're stuck with the insurance company and they increase the price. It's unethical. It's harmful. It's disgusting to have such an application of AI, although it's very accurate and useful. So always think about this 2 by 2 and remember that many of the applications are in the center. It depends on some parts of the use, social media moderation. Some of them it can be harmful, some of them can be automated, and it's kind of a combination of a human and AI interaction. There are different types of AI classification. I don't want to go through that in detail, but some of them, again, based on this notion of snake oil AI, some of them are unrealistic, and I want you to be very mindful of that. These two are realistic. You have seen those reactive AI, as I said, IBM Deep Blue, or limited memory that is like a car that another comes in front of it, I see it, and then it goes. Like you ask question from a prompt from ChatGPT, and it gives you an answer and it goes. I mean, they can keep it as a memory, but it doesn't kind of remain as a big part of knowing you. There are arguments for another type of AI, which you probably have heard in news, or some of the irresponsible or not knowledgeable, I think, journalists, that it's artificial general intelligence, means that it's becoming even more intelligent or as intelligent as human, which do not consider the realistic aspects of AI. One of them is called theory of mind, that AI understands the emotions, and the other one is a self-aware AI that is not only understands me, who is a user, but understands itself, which are most of the coming from the pop culture and Hollywood movies. But there are some people benefiting from those type of arguments, and anyways, you see it in the market. We always see those type of movies. So that makes it even more important for us to get to know. If you drive a car, such this beautiful Lexus LFA, you need to understand what is happening under the hood, not as a mechanic, but somebody who can really kind of make sure that you understand the claims and it's really useful for you. I have to wrap up, so a little bit is speed up, but large language models that we talk, we have this AI, it's large because it trains on massive amount of data. Its language means it's trained on our language, means whatever I said on social media, a book, a writing, an article, a website, it feeds in and it looks at it and it's a model. It's imitate human and it spits out words that is a sequence that is closely resembling human way of talking. Does it mean that it's smart or not? We're going to talk about it in a second. But the point is, how does it do it? It's the word prediction. So think about it this way. Is when we say once upon, most of the time you know that is after is once upon a time, right? So it runs any word that you put in the prompt when you press the enter in the ChatGPT. The first word it says sees it and it updates the vector embedding number for that word, and it predicts the next word. When the next word comes out, it predicts the whole that the next word based on the whole so far. So it's like predictability of the next word being time, given the fact that once an open and a has been used, the word time has the most probability. So it simply goes back, and anytime you talk to ChatGPT or any other AI, it goes back and runs such a number correlation type of things. And that's quite important to know rather than thinking that that's a smart thing. So having that said, always remember, it's trained on internet, on our language, not only positive and scientific books that agree or disagree with each other themselves, but also on the dark side of humanity. It can be sexist, it can be racist, it can be based on colonization information and so forth. It has that as well. Also know that LLMs don't have any core beliefs. There's not a human being there. It's just a correlation. But the companies that develop those, they have values. I never had a conversation with an AI. It's you see that beautiful picture from artwork by Tim Noble and Sue Webster. We see that beautiful picture, a shadow of a relation or a close relationship and a conversation between the two. It's okay. We use those uses of ChatGPT. Absolutely. I don't have a dystopian view, but it is important as a manager to know the stuff behind it, the correlations, not really a meaningful conversation. The fact that the mechanism for self-attention sometimes autonomously goes areas that is irrelevant, sometimes hallucinates, and we need to be very mindful of that. And that's the reason when we are not mindful of that, we see such a statistic, which is, I think, a couple of months ago, very recent. An MIT Sloan study shows 95% of the pilot projects are failing. And we have to put this in perspective. You're pretty good at project management over the past few decades. You got good at this. So 95%, it shows that a couple of things. Number one, overestimation about AI. Snake oil AI is believed. Number two, the nature of AI, the self-learning, autonomous, and black box makes the implementation very difficult. That we're going to cover it in the course. So I come back to the organizational challenge. When we see such a powerful AI and we're not really mindful of its specific characteristics and how to deal and ask the right question, we get into the productivity narrative. The very first definition, Alan Turing, it spits out something that is like human. I start thinking about layoffs. I start thinking about productivity. But the challenge is that these solutions for organizations, realistically speaking, not organizationally feasible, not technologically feasible. Why? Technologically, you're going to see that, and we talked about it, that AI intelligence is very task-based. It's decontextualized. It's black box versus human. We see people, our decision changes when you change the human, the relationship. Today and tomorrow, the comments that I give to my son as a parent is very different because every day I change, he changes. The question and the context of question changes. But AI goes with the averages. And that's the reason it's task-based. And still we need the human for significantly being improvisational with all the changes happening on a daily basis. Organizationally, it's not feasible as well. Look at Cole on the left downside, it's somewhere in the bottom in the formal organizational chart, right? But if you go and look at the informal relationship and structure, Cole sounds like a very central node in the company. He knows a lot about business processes, people, and so forth. If you decide to replace Cole, which was that guy with a bot or an AI, you probably lose significant organizational knowledge, including the tacit knowledge, which is not, you're not able to recover it that easily. So it brings back to the notion of human in the loop. But as you see on the right side, I bring back the extension of human in that it's, anyway, AI comes in, it sounds like it extends our capabilities. But at the same time, anytime that I give you hope with AI, at the same time, I make you mindful of the threats, which sounds like, oh, that's amazing. And we're going to have the human in the loop all the time. But remember, you have used ChatGPT, Claude, Gemini, DeepSeek. You have seen that AI has a lot of sycophancy, right? Anything you put in, ChatGPT says, oh, that's a brilliant idea. I love it. Let's do this. Let's do that. So it becomes like somebody with a significant sycophancy, which is not good for a manager, not good for an employee, which is very separate from the real world. But that's because of human in the loop, because we keep giving feedback, reinforcement learning trains on what human likes, it becomes sycophancy. And it's anytime I use, sometimes I go with Cloud, I found it to be a better compared to ChatGPT. But anyways, nowadays I go to any of them. If it's a kind of a deep thinking type of thing, I use it as the sparring opponent in that become devil advocate, provide counter arguments. So I have to really proactively prompt it to make it out of sycophancy mode. So human in the loop is necessary, but it has its own challenges, which makes these projects a little bit more than a little bit more complex. So getting to the end, that's the reason AI is different from traditional IT, because AI drifts for several reasons. Because it self-learns and it's autonomous and black box, you use it, the data shifts, it comes back and changes it. So the data shift leads to AI drifting. Algorithm shifts, algorithm, for the sake of more engagement, does whatever it can, including disinformation. And that will lead, as some of this, I was seeing a study last month from Stanford, and it was showing that in the competitive situations, when you give it a goal of more engagement or create more sales, it increases the sale of reinforcement learning, but it does it whatever it can, and it sometimes increases the disinformation. On social media engagement experiment, it increased almost 200% the extent of disinformation to make sure it gets more engagement. And that's drifting in AI. Context evolves too. What happens, works for me may not work for you. What happens for me now in an hour, it's not going to work. And my situation changed. And last but not least, users are also, we are all humans, and we humans are creative species. We drift in our use, which is a new data, which feeds back into the algorithm and changes the AI. And that makes it significantly important for us to be mindful of the governance of AI. So I'll finish with this slide, which is I want to kind of portray kind of a little bit of a more realistic, not dystopian, not utopian view, but at the same time being mindful of AI is not a technology. I say it's always AI is a system because it's a work in progress. It never ends, in contrast to the traditional IT. It's not a thing you install like an ERP. It's something like a plant to nurture because you need to make sure take care of the soil, which is data, fertilizer, moisture, light, every day check on it because it feeds back in the data and self-learning, and it can spoil things, right? It has a lot of bias and hallucination, as I said. It's very brittle on edge cases. It's trained on the averages. It can do a lot of harm on the edge cases. And if you ask the same question on the edge case, the answers are going to be different on and on. It's not reliable. It lacks contextual understanding. It's a long process of development. We'll see in the LUMC case that I'll teach when I come to Riyadh, but we'll see that even simplest AI they implemented successfully and it's now deployed and it's significant value for the hospital, but it was none of them less than 2 years, which is 2, 3 years. So significant work is necessary for capturing the value. We talked about the governance and the statistical pattern and the drift we talked about. So if I want to conclude, I would say AI is probably 10% technology. The algorithm that you buy, or oh, this startup has this algorithm, is probably 30. I'm just giving it a number, but I want to give you my impression of that. 30%. Three times more is the data matters. What is the quality of the data and how it's annotated? But then the 60% is the implementation. The humans who are putting it in use, the humans who have to be more creative rather than more down and kind of laid off, that those are making it working. And we'll see at UMC case with almost 4 or 5 pilots, we go into the details, all of them successful, but very differently with considering the specifics of AI in that case. So these were kind of pieces and parts from the course that I teach. Definitely I didn't go through that all. I would be happy to talk about it. If you want to know a little bit more, sometimes I put it on the podcast. I'm not a good podcaster. But I sometimes put it there for my students to listen. But if it's helpful, we can go there. And I thank you for listening. I'll be happy to answer any question. I'll stop here. I don't know whether I was on time or not.
Thank you very much, Professor Yasser. It was really beneficial. And a reminder that webinar is a preview. Professor Yasser was nice enough to come to Riyadh on December 17 in person, and we will run with him a full day AI fundamental and strategy for manager. So this is just a preview. We have still 20 seats available. All the information are posted on the chat. And I believe we can take a few questions if there's any question on the chat. I think, Ahmed, you had a question about, I think at a certain moment you said, you asked about, is this similar to the recency effect and how does it correlate? If you want, you can ask the full question about which specific point. I don't know if Ahmed is still with us. But maybe Professor Yasser, if you can spend like 1 minute to tell us about the actual project or program.
Yes, hi. Sorry, I was not able to unmute myself. Yes, I had a question regarding one of the recent slides. So, since AI model learns and answers and the old information is obviously updated with the new one. And AI often misunderstands by accepting answers, like even Chat GPT. If we give it new information and then we ask about it, about the old one, it says, okay, so I made a mistake, maybe you are right. So it does not validate. Can you shed some light on it, because of the concept which you were talking about?
No,
So
that's excellent question. Thank you for
yes.
asking that. That's you're spot on. So in other words, if even if you ask it to play devil advocate, it goes correlationally. So it's stochastically looking at whatever data can contrast that. So there's not a meaning into it. And sometimes, as you said, it's just dumped the idea. Oh, you're right. Sometimes, as you said, I go and say I disagree with this for that reason. Yeah, you're right. I was mistaken. And again, if you disagree, it's going to completely flip it. So that makes it, if I want to make an argument, I can get arguments from ChatGPT. But again, does it make sense or not? Is it meaningful in that conversation? It's still your decision. And if you go with AI, it's going to go in terms of randomness. You're absolutely right with the respect to the recency in freshening the data. So it may go autonomously to a recent data, another thing, but it doesn't mean that it's really making it more meaningful. I also add, it's kind of a solid, I randomly spot on AI. Sometimes it's very difficult nowadays to catch up in different disciplines. Many from different domains, not only computer science are studying the concepts, but I was seeing a concept of a context window, which means that the very initially you train an AI on a big set data set, or the first 10%, 20% has the most impact on AI's kind of a framework of argument. The more you give it the data, it kind of doesn't consider it as much as an A fresh as the one that it initially said. So it gets it incrementally improved. Versus then the computer scientists have to do different methods to consider it like a new type of recent data that you may consider differently. In other words, it goes towards a trajectory of recall thinking, but AI doesn't think. It's not going to change it radically. It just sticks to it and it sees that trajectory as it is. So back to you. I don't know the answer, but I totally agree with what you raised as a challenge for use.
So maybe I'll ask you a follow-up question. Like a lot of people talk about hallucination, about so how is I think and yeah, I agree. I mean, sometimes I'm using Gemini or ChatGPT and I say, and they make stupid like even mathematical errors. And I have one I posted on Twitter like a couple of months ago where Gemini was completely wrong in a simple mathematical like addition of numbers, and I recorded everything and I showed like, how can it be that smart if and then there's, oh sorry, I made a mistake.
Yeah. So it's a great point. So I think I don't know whether I saw this, but it sounds like I think it makes sense to all of us. In some questions or situations, AI is Einstein, and at the same time, it's a toddler in another question. So intelligence is multidimensional. It's not just like running numbers. At the same time, we have a lot of emotional intelligence. We have spatial intelligence. Think about robots. Things that are so difficult to train a robot is so easy for a human being, which is picking up, for example, my water bottle. So when I pick it up, I go my hands very smoothly, touch it and pick it up. But for robot, it hits it, it doesn't get it. So it doesn't have a sense of the space and how big it is. The same thing for what you said is that I think part of it goes with autonomous aspects of AI and self-learning multiply, because it automatically may see another thing having correlation, which for us is so easy not to have correlation. I once asked, I think they have revised it. I hear it somewhere and I tested it myself and that was right. In that I asked ChatGPT, if I have one shirt that it takes 1 hour to get dried in the sun, how many hours will it take for 5 shirts to get dried? And it said 5 hours, right? So for ChatGPT at that time, it was simple that, okay, one shirt takes 1 hour to get dried, 5 shirts, 5 hours. But for me and you, it's so simple. For a kid, it's simple that it doesn't matter. You put it in the sun, all of them are going to get dried, right? So it's what it's that ChatGPT attends at that moment, and whether it's meaningful and relevant or not, these are randomness. It goes back another factor of the drift that I mentioned is also user interaction. I realized that when I changed a couple of words, just swapped them the way my writing was, it gave me the right answer. it gave me it's going to be 1 hour. So that's what I mean by it. The AI is so brittle on edge cases that just putting two words and separating or switching their place in a prompt made a radically different answer, which makes it, again, more important that this is, we know we can't completely control hallucination. We're mindful of that. We use it for extension of some of capabilities. But again, responsibility is with ours because it's going to hallucinate, as you said.
So going back to the program that we are going to run on December 17, as a manager, why should I sign up to that program? It's a full day, it's in person, it's in New York. This is the first time we are running this workshop. So if I am a manager and I make a decision, right now every manager has to make a decision. Is the solution that we found that says, oh, AI will solve all my problems. So what are maybe the one or two things that this program will help me in my daily activities?
Awesome. So I actually had just finished the program 2 days ago, a similar program in Bahrain with brothers and sisters in banking industry. Quite a similar program in that makes them mindful of, as managers, what are the decisions that they need to make. So in that program, what I do is that we have gone through some of the fundamentals. We a little bit dig down on a couple of things. But I teach with cases. I don't come with lectures like this time that you saw, because this is the nature of this conversation. But in that case, I'll give people like 6 pages of a real story of Grow company that I mentioned. It's an AI development and they have a decision to make. So I'll put you in the hot seat in the cockpit of you make the decision. What would you do if you were the manager of that company? And you have all the data that you need. And you get into groups and with your colleagues that you don't know each other, but it's actually an excellent opportunity to learn from each other. You have different reactions and different decisions, which are managerial, none of them technical. Then we come back and we see what are the specifics under the hood as a manager of that application, which one of the decisions makes more sense and which one less sense, but not only that specific decision. We articulate criteria that is kind of agnostic of that company and that situation that you can always do. That's like half of the workshop on machine learning development and its implication for manager. What are your decisions in that process? On the second part, we go with, as I said, 60% implementation. We go with the real world implementation of AI in a large Dutch hospital over 6-7 years with a lot of failure and a lot of success. And the successful one, we pick 4 of them in the story. Again, I give you the story of that. People read it, or I have a podcast of it that you can listen to the podcast when you're driving and come prepared to the session. With the decision, we're going to dive into a real case and seeing what are the real specific challenges of AI development and implementation in a real world. And what do I learn from it as a manager? And I found it's consistently helpful for people, especially when they come out of their domain. So I teach this LUMC hospital case to bankers because it's similar for them. It's very heavily regulated and radiology is digital. And it gives them an understanding of, I can do this, or I can't do that, or I do it this way, not that way, when I go and implement AI. And I found it to be quite an empowering moment for them.
So again, to reiterate what you said, this is not a lecture. This is going to be hands-on case study based on real like cases that we worked with in the past, that we solved in the past, and we are not solving it. We are going to work with the 20 to 25 people who are going to be in the program, and we will divide them into groups, and they are going to look into how do they solve them themselves, and we will guide them. So this is the best way to learn versus a lecture kind of thing.
Exactly. I think this is what Ivey is good at. Actually, I have done this approach in executive education, in undergrad and MBA. I have done it even in high school. It's funny that sometimes I go to high school, my son, and I do some of these cases on AI bias, for example. I throw them in the situation. This is the situation. What would you do? And people come back with fantastic experiences, but I kind of torture the comments, and collectively we get to the takeaways, which is agnostic of that case. Goes beyond that case. It's always more fun, and I think in a more fun environment we learn better rather than just sitting down bored like now about Yasser lecturing us. So that's more
I agree
fun.
with you. Yeah, I agree with you 100%. I think I always like the same thing. I talk to some of my friends, like it's easy to teach someone, like, to give them a fish, like here the solution. But it's more important to teach them how to fish, how to make a decision with AI. How do you differentiate between, there's a lot of fluff out there that people are claiming they have the best solution. AI will do everything, and you have to decide as a manager which one is true, which one is fluff. Like you said, the Harvard study and many studies are saying 90% of anyone who is claiming he has an AI solution is not going anywhere, and it's failing.
Exactly.
So that's mean that 90% of the people who are coming to you as a manager trying to convince you to take their solution, you have to double check and triple check.
Exactly. I'll show you in the LUNC case, some of these startups who joined the hospital and develop algorithm, not only they were successful, but now they got out of Europe and now they got the FDA approval and they're in many hospitals. So it's a real world AI application that got integrated in the workflows. And I have a few of them, but we kind of completely together unbundled it in groups. We get together. I need a big whiteboard, Salim, in that room, because everything is less of a lecture. It's kind of sketching, putting things on the board, and it's more fun. I always enjoy it and learn from the participants.
Again, thank you very much, Professor Yasser, for coming to this webinar. Thank you for our partner, ES Learning, and let Hamza maybe say the last few words. But again, for anyone who wants to join us on December 17, we are posting the link. Please register. We have only 20 seats available, and we are giving a discount for the next, I believe, 2 or 3 days. So we want, like, to share this experience and this learning with everyone. With that, maybe Hamza, you give us the last few words, and we'll close this webinar.
Thank you, Salim, and thank you, Professor Yasser. It was a really interesting session. We are looking forward to hosting and welcoming everyone to be part of the in-person session that's happening at Ivey and ES Learning in Riyadh. So please don't miss this opportunity and be part of the change coming in terms of AI. I think the team has posted different links. You can use those links to be part of the event. So thank you so much, Salim. Thank you, Professor Yasser. And thank you, everyone who has attended this session. I hope that you have learned at least a few things from the session and be eager to be part of the next session, inshallah. So if you want to say something, Professor Yasser, and we close it.
No, that's it. I was very happy and honored to be presenting. I hope to see you in Riyadh. Inshallah, we get together and have fun and learn together.
Yeah, thank you so much. Part of this session was our expert in AI, engineer Bassam Al-Farashi. So he has been doing some of the webinars lately. So just hands up for him, and thank you everyone. Thank you so much, Professor Yasser.
Thanks everyone in the support. I appreciate that.
Thanks. Take care. Bye.
Assalamu alaikum.
Salam.